Here we have a block release from rest at point A at the top of a quarter circular incline. The incline is frictionless and the block slides down to point B. At point B, the block transitions to a flat, rough track. Block eventually comes to rest at point C. Draw the forces acting on the block at point P and Q. Okay, so we'll start here at point P. Whoa! Sorry. At point P, we have the weight force acting down, and we also have the normal force acting perpendicular at that point. Because there is a normal force on a different plane, we would say the centripetal force for this situation would be Fn minus mg cosine theta. And that could equal m times v squared over r, right? That's not what we're doing here, so you don't have to worry about that. That was just a little bonus for you. Instead, it just says draw the forces acting at these specific points. So we've got our normal force there. It's frictionless incline, so we don't care about friction. Meanwhile, at point Q, we do care about friction. We have our weight force and normal force canceling each other out as we're on a horizontal surface. We are sliding to the right. Friction always opposes the direction of sliding. Kinetic friction dissipates energy. Remember, we have two types of frictional forces. We have static frictional force and we have our kinetic frictional force. Static frictional force does not dissipate energy. Meanwhile, the kinetic frictional force, the sliding, this does dissipate energy. It's important to know the difference between the two when we're dealing with energy. At point A, we want to draw the energy bar charts happening. So it looks like our total energy at point A is just going to be gravitational potential energy. We can calculate this to get quantitative bar charts. Mass was something, G 10, H is something. Okay, we don't know the numbers here, so we'll treat these numbers as percentages. 100% of the energy is gravitational potential energy here. At point B, we are moving, but we have not yet hit friction. So all of our energy has been converted into kinetic energy. And then at point C, we have negative work that has taken care of all of that energy. We're just sitting there.